All right, and in the last part of question 5, we're going to use the geometric progression for 1 over 1 minus x to derive a power series for 3 over x squared plus x minus 2. So how can we do that? Now, to do that, we need to use partial fraction decomposition, right? So we need to change the given function to partial fractions. Well, partial fractions usually help in calculus whenever for whatever you do, so be it power series, integration, um, well, differentiation probably is not really important. So in future, when you do Laplace transform, for example, Laplace transform is also done on partial fractions. It is an extremely useful technical tool to work with rational functions, right? So to do partial fraction decomposition, first we solve the quadratic in the denominator. So x squared plus x minus 2 is 0. The discriminant here is 1 plus 8, which is 9. So the roots are minus 1 plus minus square root of 9 is 3. 3 over 2, so which is minus 2 and 1, I think. Okay, so it means that x squared plus x minus 2 is really x minus 1 times x plus 2. And 3 over x squared plus x minus 2 is going to be a combination of 1 over x minus 1 and 1 over x plus 2, while with the minus sign. And basically, what I'm going to do, I'm going to try, well, suppose that if this were a 1, then uh, the numerator is going to be x plus 2 minus x minus 1, so which is x plus 2 minus x plus 1, which is just 3. Right, so if I just write 1 here, then the answer, the um, the numerator of the fraction is going to be 3, which is precisely what I want, right? So essentially it means that I don't really need to change anything. So it's going to be just 1. Okay, good. Okay, so it's going to be just 1. Okay, and now I've got to represent this. I've got to change it to the right form, to something that looks like this. 1 divided by 1 minus something, right? Okay, the first term here is 1 over x minus 1. So it's easy. So it's just 1 minus 1 minus x. And to get the right form for the second term, I've got to take out 1 half, right? So 1 over 2 divided by 1 over 1 plus x over 2. All right, now basically I have two kind of independent equations here. So, and for the first one, I'm going to construct its own power series, and for the second one, I'm going to construct its own power series. So the only thing that I probably will take care of from the beginning is basically this works if x is between negative 1 and 1. And this works, so notice that here, um, well, I should really have minus something. So then I will rewrite it as 1 minus x over 2, right? Okay, so this really works if minus x over 2 is between negative 1 and 1, so which means that x is between negative 2 and 2. Okay, now the smaller of the two intervals is the first one, all right? So if x is between negative 1 and 1, then the first term is well defined, and the second term is also well defined since 1 is less than 2. So which means that the answer here is going to work for x between negative 1 and 1. Okay, so at least that much is clear, so I don't have to take care of the domain anymore. And now basically the idea is that I'm going to use my power series using, well, the first of them is just minus 1 plus x squared plus x cubed plus and so on. And the second is minus 1 half, so minus 1 half times 1 minus x, sorry, let me write it like this, minus x over 2 plus minus x over 2 squared plus minus x over 2 cubed, and so on. Okay, so let me rewrite it a little bit. Now, the first term is going to be just uh, the sum of from 0 to infinity of minus x raised to the power n, plus the second power series is again the sum from 0 to infinity minus 1 half times, well, x over 2 minus x over 2 raised to the power n. Well, I guess this is the sum from 0 to infinity. We can take out x raised to the power n, and the coefficient here is going to be just minus 1, and here is going to be minus 1 over 2. There is 2 here and 2 to the n here, so it's 2 to the n plus 1. And there is a minus sign here, so it is raised to the power n, and there is one more negative sign here, so this minus 1 raised to the power n plus 1. So I can just replace this with a plus sign, minus 1 half raised to the power n plus 1 x to the n. Okay, and that's going to be the answer. So the answer is well defined. So the domain is the interval from -1 to 1. Yeah, let me check if I got it right. I have official model answers here, and yeah, I got it right.